Today we're going to study simplification of complex rational expressions. First, let us define complex rational expression. A complex rational expression is a rational expression in which the numerator and or the denominator contains a rational expression. Let's have examples. The first example is this. I have a numerator which is a rational expression, and that is 15 over x minus 3, and the denominator is another rational expression that is 3 over x squared minus 9. The next example is a numerator which is a sum of two fractions, that is 1 over x plus 1 over y, all over the denominator, which is the difference of two rational expressions, that is x over y minus y over x. In this video, we are going to consider two methods to simplify complex rational expression. The first method is simplification by division. The second method is simplification using least common denominator. Let us first discuss the method 1, how to simplify complex rational expressions using division. We have 3 steps. Step 1, simplify the numerator and denominator. Step 2, rewrite the complex rational expression as a division problem. If we have a over b, where a and b are rational expressions, this will be equal to a, the numerator to be the first rational expression, divided by b, which is the denominator. And step 3, we will divide the expressions. Let's have example 1. Simplify this rational expression. The numerator is 15 over x minus 3 all over the denominator 3 over x squared minus 9. Step 1 says simplify the numerator and denominator. We can observe that the numerator and the denominator are both in simplified form. So we can go to step 2. Rewrite the complex rational expression as a division problem. So writing this again into this form, it becomes 15 over x minus 3 divided by this rational expression 3 over x squared minus 9, which is the denominator of our complex rational expression. And step 3, we will divide the expressions. We know that in division, we are going to first copy the first rational expression, and then for the second rational expression, we are going to take the reciprocal. It means here the number 3 as numerator becomes denominator, and the x squared minus 9 as denominator here becomes the numerator. Also, the operation is changed. From division, it becomes multiplication. And when we do the multiplication, we need to first factor out all the numerators and denominators completely. The number 15 becomes 3 times 5. The x minus 3 is simplified already, so we'll just copy that. The x squared minus 9 can be factored out into x plus 3 times x minus 3. All over, that number 3 is copied down here. And then we can cancel common factors in the numerator and in the denominator. The number 3 is common, cancel that, and also this number 3 in the denominator. The binomial x minus 3 is common in the numerator and in the denominator that we can cancel. So after the cancellation, we will collect the remaining factors. So the number 5 is here, and the x plus 3 is here. In the denominator, all are cancelled, so that is equal to 1, and we don't need to write. So our final answer is 5 and the binomial x plus 3. Let us have example 2. Simplify this complex rational expression. In our numerator, there is a sum of 2 rational expressions. In our denominator, there is a difference of 2 rational expressions. Step 1 says, let us simplify the numerator and denominator respectively. So I'm going to apply the crisscross method in the numerator and denominator. So this is our method. This number 1 here, I'm going to multiply diagonally to the y. The answer is y, so I'll put the y there. And then the operation is plus, I will copy the plus. Next, this x, I'm going to multiply diagonally to that number 1. So x times 1 is x, I will put the answer here. Then all over, I will multiply the denominators, x times y. So xy, I will put the answer here. So the same idea I will use for our denominator down here. So crisscross method, x times x is x squared, and then minus, I will copy here. Then the y times y is y squared, I will put the answer here. And then multiply the denominators, y times x will be yx or xy. And step 2, let us rewrite the complex rational expression as a division problem. So it will be like this. This is now our numerator. The y plus x, I'll just put it as x plus y. There is no issue on that. So it will be x plus y over xy divided by our denominator here, the x squared minus y squared all over xy. And step 3, let us divide the expressions. It means I'm going to take the reciprocal of the second rational expression and take it here. See now, the xy becomes the numerator, the x squared minus y squared is now the denominator. The operation now changes from division into multiplication. Our first rational expression, there is no change. We will simply copy here. And then we're going to factor out the numerator and denominator completely. For our first rational expression, the numerator and denominator are all in simplified form. There is no change. The xy in the numerator, there is no change. Only the x squared minus y squared can be factored out into x plus y times x minus y. And from here, let us cancel the common factors in the numerator and denominator. The x plus y is common with the x plus y down here, so we can cancel that. Our xy here can be cancelled with the xy down here. So after the cancellation, we will collect the remaining factors. In the numerator, nothing is left, so we will put 1. In the denominator, only the binomial x minus y remains, so we will copy that. So this is our final answer, 1 over x minus y. Let us discuss now method 2, how to simplify complex rational expressions using least common denominator. We have 3 steps. Step 1, find the LCD of all fractions in the complex rational expressions. Step 2, multiply the numerator and denominator by the LCD. Step 3, simplify the expression. Let us have example 1, simplify using LCD. This is actually the same example that we had in our method 1. So we will solve it again using the method 2. Step 1 says, find the LCD of all fractions in the complex rational expressions. There is a fraction in the numerator. There is also a fraction in the denominator. First, let us collect all the denominators. So the x minus 3 is now here. The x squared minus 9 is now here. Let us find now the LCD. Let us factor out these two denominators. The x minus 3 is already in simplified form, so we will just copy that. The x squared minus 9, the factors are x minus 3 and x plus 3. So we are going to write the common factors in a column. So for the LCD, we are going to write all the factors, and in case of common factor, we are going to copy it one time. That is why in here the x minus 3 is copied once, and also the x plus 3 is copied also. So the LCD is x minus 3 times x plus 3. And then step 2, multiply the numerator and denominator by the LCD. Before we go to step 2, all the denominators must be expressed in factored form. So the 15 over x minus 3 is already simplified, so I'll just copy it here. The 3 over x squared minus 9 is copied here, but the x squared minus 9 is now factored out. Going to step 2 now, multiplying by the LCD, it will be like this. And then let us cancel some terms that is common in the numerator and in the denominator. Look at our first group in the numerator. The x minus 3 can be cancelled with the x minus 3 here. In our big denominator, the denominator here is cancelled completely with the LCD. So let us collect the remaining factors. In the numerator is 15. Also this binomial x plus 3. So it is now copied here. For the denominator, only the constant 3 remains, so we will copy that. And step 3, simplify the expression. The 15 and 3 can still be cancelled out. So the 15 becomes 5. The 3 is now cancelled into 1, so we will not write it anymore. So the 5 times the binomial x plus 3 is our final answer. You can pause the video and go back to our example 1 in method 1, and you will see that the answer here and our answer in our method 1 are exactly the same. Let us have example 2, simplify using LCD. Also, this is the same example that we had in our method 1. So we will solve this using our method 2. Step 1, find the LCD of all fractions in the complex rational expressions. I can see here that the denominators of all the fractions in this complex rational expression are all x or y. So all denominators are here now, and if I'm going to write the LCD, just simply copy the x and the y together, and our LCD is xy. Next, multiply the numerator and denominator by the LCD. So it will be like this now. So the xy, the LCD is multiplied to the numerator, also in the denominator. And then this xy will be distributed to the 1 over x, also the xy times 1 over y. The same idea with our xy here to be multiplied with the x over y, and then xy times the y over x. So it's now like this. So we have now 4 groups here, 1, 2, 3, 4, and then let us cancel some terms that we can cancel. In our first group, the x can be cancelled with the x. So when we cancel that, it becomes 1 times y, it is y, so we copy the y down here. In our second group, the y in the denominator and the y here can be cancelled. So 1 times x is x all over. In the third group, the denominator y can be cancelled with the y here. So what remains is the x times x, and that is x squared. So the x squared is now here, and then minus. In the fourth group, we have this x can be cancelled with the x. So what remains now is y times y. It is y squared. Next is to simplify the expression. In the numerator, we have y plus x. We can rewrite this as x plus y. And the denominator, x squared minus y squared, can be factored out into x plus y times x minus y. The x plus y is common. We have here and also here, so we can cancel that. And the next step, we will just collect the remaining factor. In the numerator, it is now 1. In the denominator, it is now the binomial x minus y. And this is our final answer. If you want to check the answer in our method 1, you will see that they are exactly the same. Problem 1. Simplify 2a over a plus 4 all over 4a squared over a squared minus 16 by writing it as division. We have here a complex fraction. In the numerator is a fraction, while in the denominator is another fraction. Writing this as division, we write this numerator as a fraction first, divided by this fraction in the denominator, just like this. So let us divide. First, we invert this second fraction. This is the divisor. After inverting, we multiply. So this becomes 2a over a plus 4 times a squared minus 16 all over 4a squared. Now, let us do some factoring on some of the terms. In the first fraction, it will be same times the a squared minus 16 becomes a plus 4 times a minus 4 all over the 4a squared. Considering the 2a here, we can write 2a times 2a. Then let us cancel out 2a by this 2a. Also, a plus 4 is cancelled with a plus 4. Then we collect the remaining values. So we have a minus 4 all over 2a. Problem 2. Simplify 5 over the trinomial c squared plus 5c minus 14 all over 10 over c plus 7 by writing it as division. We have here a complex fraction. In the numerator is a fraction, while in the denominator is another fraction. So we copy this numerator fraction divided by this fraction in the denominator. Let us now divide. First, we invert the second fraction. Then we proceed to multiplication. So it becomes c plus 7 now all over 10. Let us do some factoring. For this trinomial, we can factor it out as c plus 7 times c minus 2. While for the number 10, considering the number 5 here, we can write 2 times 5. Let us do cancellation. This 5 we cancel with the number 5 down here. Then we cancel the binomial c plus 7 and this c plus 7. So finally, we have 1 in the numerator all over this 2 times the quantity c minus 2.